Okay, let's give you guys some more practice. So find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, you're supposed to remember this. You're supposed to remember this, and we've seen this before in the past. If you look at this, this is very similar. This whole thing here is very similar to this, but the only difference is that this thing here is a negative and this thing here is a positive. So what you do is you push this negative inside the bubble here, so that will become positive, and then you've got your minus 1. So now this is very similar to this, because if you look at this, to the power of n, you've got 1, 1, and then you've got a positive and a positive here. So now if you look at this, x then becomes this. So this is like x then becomes this. So you're supposed to remember this, and then from here you can jump to here. Try to force yourself to remember this. Whenever you see something of the form 1 plus something to the power of n as n tends to infinity, try to remember this limit, because it's quite important. So yeah, try to remember this limit. But let's say you're faced with this, and then you can't remember this. So you can't apply this. Let's say you're faced with this and you can't remember this. So you're trying to find the limit of this. So you're trying to find the limit of this. You can't remember the formula, so you're trying to find the limit of this. So let's just say y equals this limit, and it is a y that we're seeking. We are trying to seek y. So now from here, natural log equally to both sides. That will then give you this. This n will come down, so that will give you this n, and then natural log, the bubble here, the bubble here. So now let me think. Now you're trying to find the limit of this. So here you can visualize it as one block multiplying another block. So as n tends to infinity, this thing here is going to head towards infinity. And then if you look at the bubble here, as n tends to infinity, this is going to be 0. 1 take away 0 will be 1. So this block here will be natural log of 1. So natural log of 1, so this is 1 here. Natural log of 1 will be 0. So you've got infinity times 0, which is an indeterminate form, and at the moment it's a product. So the trick that we would normally use when it's a product, we would rewrite this as a quotient. So rewrite as this. So this is a trick that we've used many times in the past. So rewrite this as a quotient. Now as n tends to infinity, this is going to be 0, and then this thing here, as n tends to infinity, this is going to be 0. 1 take away 0 will be 1, natural log of 1. So natural log of 1, that's here, that will be 0. So here you've got 0. So as n tends to infinity, you're going to have 0 over 0, which is an indeterminate form. So now you can apply L'Hopital's rule. So applying L'Hopital's rule, differentiate this, that will then give you this, and differentiate this, that will then give you this. When you come to differentiate this, imagine that, well, do whichever method you want. You should be able to differentiate it by now. So imagine this as being a bubble. So it's going to be 1 over the bubble, which is this bit here, which is 1 over the bubble here, and then you've got to times the derivative of the bubble itself, which would be this. So when you come to do this, imagine it as n to the power minus 1. So this comes down, blah blah blah. You should be able to differentiate this, and then now tidy this up. So it's just a matter of tidying this up. So blah blah blah, tidy this up. That will then take you to here, and then tidy up. That will then take you to here, and then tidy up. That will then take you to here, and then now as n tends to infinity, here you've got one bubble, and then here you've got another bubble. As n tends to infinity, you're taking away a minute amount here. So you can imagine this whole thing as being minus n over n. As n tends to infinity, let's say as n tends to 9,999,999, and then you're taking away this tiny amount. Let's just forget this tiny amount here. So you can imagine this thing here as being like this, which will have a limit of -1, which will have a limit of -1. So now e equally to both sides. So e equally to both sides. So that will then give you this, And then in a way these two cancel out, giving you y, and then you've got this thing here. So so the limit is e to the power of -1. Okay.